Okay, here we go. Um, our next section, chapter 2. Calculus is going to start to turn to kind of more algebra and graphing and factoring and stuff like that that you're used to within but we got to get through this chapter first, which is 2.4 to 2.6. I will say that generally this is as high of scoring or even better of a test than the previous one. So after that, it starts to get a little bit hard. Okay, so today is not something that you're going to walk away and just fully get and understand. It's going to take us 3 days. Okay, but today you will be capable of doing your assignment, and you'll get a little bit of time to do the first two problems. Okay, you ready? This is the big idea. We need a precise definition of a limit. So far, our current definition for a limit uses phrases like as x approaches 0 and f of x gets closer to some limit. And these phrases are problematic. And the reason why is this. How close to 0 do we have to get in order to be confident in our limit? For example, if I draw a line and it's x plus 1, and I'm looking at the limit as x goes to 0 of x plus 1, you guys are all confident in saying that the limit is 1, because you can plug it in and you understand that that has a height of 1 right there. The fact is that you can anticipate the behavior of that. You know it's a line. You know that crazy things don't happen with it. Well, what about something like that? Take out your calculator and let's plug in this, or watch mine. I'm going to plug in this function, y equals, I have 5x squared times the sine of 100x, all divided by x. And in my mode, I'm in radians, and I'm going to zoom standard, and we're going to see what we get. And so I'm approaching 0. Can you say with confidence what the limit is as x goes to 0? Can somebody make a general guess? What's your guess? You're going to guess 0, you're going to guess 2. Any other thoughts? Okay, 0, 1. How about negative 1/5? There's all sorts of thoughts right there, okay? All sorts of guesses. What if it doesn't exist? That's a possibility as well. You're the man. Yeah, but it might be starting. All right. All right. So here we go. What if you wanted to be more confident in your limit? What would you do? Let's zoom in. What does it look like now? Negative 0.25. Are you confident in that? In order to be confident, what would you do? And we'll pick up. Now it looks like it's up there. We'll check it out when we get back. Get some brain food. This, okay? Here we have this limit. And you guys have said that you felt that the limit was more around negative 0.25. What does it look like it might be now? Like maybe like 0.6, 0.06? So are you really confident in that? So let's zoom in again. And now what would you say is the limit? It sure looks 0. And if we got to zoom in again, if we got 0 again, we could be much more confident. I'm very confident at that point. Wouldn't you guys agree? So look at what had to happen, okay? Here's where we're at. Consider this function. Well, it goes like that. Well, how do you know what the limit is? It's so difficult to be able to tell as you look at it. So why is it difficult to calculate this limit? The behavior. Is unpredictable. So what would you do to be confident in your estimation? We would zoom in. And in fact, we went from a 10 by 10 window, we moved that. If you look at our window, we moved it to a 0.04 by 0.04 window. So the big question is, how far do we have to zoom in to make sure that we are confident in the limit? And in mathematics, we don't assign a number like 0.04 or 0.1 or 0.0002. Here's what we assign for a value. We will zoom in that far. The infinitesimal, the infinitely small, to verify that it is for sure the limit that we think. We'll teach you how to do that. And that should make your brains explode, okay? So, you're not going to understand this right now, but what we are going to do is we are going to write down the precise definition of the limit right now, okay? We're going to write down the precise definition of the limit. This is what you're going to have to memorize verbatim for the test. And trust me, you'll be excellent at it because we will practice. The first thing that we do is we draw a function with an open spot at A. Can everybody remember that picture? Can you keep that in your brain? Is that something that you could commit to memory? In order for a limit to exist, does there have to be a closed circle? No. So, we start out the definition by stating the premise. Let there be a function. That thing that I drew. Defined on an interval. But maybe not at point A. You okay with that? No, we got a lot more. Then let's make a statement. The limit as x approaches a of the function is equal to L. Or the limit exists. The limit is equal to L. If, now here's what we're going to say. If we can create a small enough window to be confident. But the way we say that mathematically is this. If for every epsilon greater than 0, epsilon is this is the lowercase Greek letter for E. Epsilon greater than 0. There exists a delta. Delta is the lowercase Greek letter for D right here, greater than 0. I'll draw a few more deltas. Sometimes my first one isn't very good. Those are all greater than 0. I said less than. My apologies. For every epsilon greater than 0, there exists a delta greater than 0. That satisfies the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus a is less than delta. Done. Absolute value. So let me show you what it means, and then we'll try an example. Like I said, you're not going to understand all today, but after 3 days, we hope you understand it. What does it mean for epsilon to be greater than 0? Something greater than 0 is simply positive. So epsilon is just a certain distance. So this is plus epsilon, and then this would be, say, minus epsilon. There's an epsilon greater than 0, so that when you go on either side of the limit, it corresponds with either plus or minus a certain delta from your a value. And we can decide how small to make this epsilon. For example, in our very first calculator example where we looked at the graph, we made it 0.04. Well, we could make it 0.000000004, right? We could make it really small. The idea is that we're going to create a window small enough so that you can say confidently, yes, we know exactly what the limit is. And we are going to make it so small that epsilon will actually be 1 over infinity. It will be as small as you would ever want to choose. And so today we're going to do an example that you will take and use for your homework assignment, which is a worksheet, and you'll have success with it. We're going to graph the function 1 over 2x, which looks like this. And it says find an interval for x values that will satisfy y values will always be within 0.2 of the limit as x goes to 2. As you see these type of problems, you always want to start by writing your limit. So we're going to state that the limit as x approaches what? What are we approaching? X is approaching 2 of the function. What is the function? 1 over 2x. Can you plug in 2 to that? Are you able to plug it in? And what do you get? 1 over 4, 0.25. Very good. So epsilon is our tolerance. We want to be within how much? 0.2. So I'm going to start to mark this out. I have an x value of 2. And I have a y value of 0.25. Everybody agree with that? So here's what I'm trying to do. I'm trying to find a delta value given an epsilon value. What is our epsilon? 0.2. So if I go 0.2 up, where does that bring me to? 0.45. You have to understand right now how I came up with these values. I took the limit and I added onto it 0.2. Now I'm going to subtract off 0.2 and get 0.05. Is everybody okay with that? So I'm going to draw those over. I want to find the input that gives me an output of 0.45. So what is the x value I would plug into the function that would get a value of 0.45? Do you know how we figure that out? Take 1 over 2x and set it equal to 0.45. So the mathematics here is pretty easy. The algebra is pretty easy. How do I solve for that? What do I do? Cross multiply, I get 0.9x, or 9/10 x is equal to 1. Multiply both sides by 10 over 9. I get x is equal to 10 over 9, or 1.11. Okay, I got to find the other x value. So I don't just have to do the 0.45, I also have to do the 0.05. So I take 1 over 2x and set it equal to 0.05 over 1. How do I solve that? Cross multiply, and I get 0.1x is equal to 1. Now what? That's 1/10, right? So x is 10. Epsilon is equal to 0.2, okay? That's the difference between these two spots with the limit value. So delta will be the distance between the 10 and the 2. So what is delta? 8. And, or we'll check this one. 2 minus 1.11 is 0.89. You always choose delta to be the smaller value. Delta equal to 0.89 is our answer. If you want to ensure that all the outputs are within 0.2 of the limit, you need to make this window. And that will ensure that the limit is 0.25. So today, you're going to be given an epsilon value, and you will find the delta value. Let me give you your worksheet. We'll do one problem together. Okay. So let's look at your first example. My wife knows the passion that I have for mathematics. Yes. Okay. So the first one says we have the limit as x goes to what? Help me out here. What are we approaching? 3 of 2/3 x minus 1. Okay. And we have our tolerance, or epsilon, is equal to 1. And we have epsilon equal to 0.5. So first of all, what is that limit? Can you plug in 3? Yeah, 2/3 times 3 is 2, minus 1 is 1. Good. So we're going to graph this. Looks something like that. Okay. And I'm going to approach 3. And it says I'm going to have an output of 1. So, any confusion how I started? Yep. Sure. Epsilon is 1. So if I go 1 up, where does that bring me? And if I go 1 down, where does that bring me? So I go over, and then I go down to the x-axis. 0, I'm already there. Okay. Don't need to drop it all. So we want to find this x value, and we want to find this x value. We have epsilon values of 1. Once we find the x values, we can find the delta values. How do we find those two values? What do we do? 2/3 x minus 1 is equal to 2. Solve. How do we solve? Add 1, so we get 3 multiplied by 3 halves. So x is equal to 9 halves, or 4.5. How do I find the other spot? Same thing. 2/3 x minus 1 is equal to 0. So 2/3 x is equal to 1 multiplied by 3 halves. X is 3 halves, or 1.5. I have to now answer what delta is. Delta is the difference between the x value and the point that I'm approaching. What is the difference here? 1.5, or 1.5. What's the difference between 3 and 1.5? It's the same in this situation. If it's not the same, you choose the smaller of the two. So answering delta is 1.5 is the correct answer there. That is the value that would give us a small enough window to guarantee that all the outputs are within 1 unit of the limit. you do the 0.5 one on your own. If you choose 0.5, what's going to be your top point? And what's going to be your bottom point? Go ahead and finish it off. Find your x values. Your x values will then lead you to your delta value. I'm going to stop this because I'm going to come around and check, see if you get it. And you'll be ready to work through the rest of your assignment.